This is Lesson 1, Part 3. We'll be talking about the transformations of cubic and quartic functions in a little more detail and how to write an equation of a cubic function from its graph. So the generalizations about transformations of cubic functions. This is the vertex form of a quadratic. And I know it's a quadratic because of the squared. Okay, here is a transformational form or the vertex form of a cubic, and I know it's a cubic because of the 3. And then this one is a quartic. Because of the 4. It tells you the stretch that's happening. So really you're looking for, when you're looking at transformations, you're looking for 4 specific things. You're looking for horizontal movement from the parent graph, and the H tells you that horizontal movement. You're looking for vertical movement, and the K tells you that vertical movement. You're also looking for if it's stretched. If there's a stretch, you're looking to see if it's narrower or wider. And if there's a number, if A is different from 1, then you know that it's either going to be narrower or wider. If it is greater than 1, if A is greater than 1, you know it's narrower, and if it's less than 1, then you know, or between 0 and 1, you know it's going to be wider. And then the last thing that you're looking for is to see if it is reflected. If it's reflected, it's going to have a negative sign in front of the A or in front of the parentheses. So 4 things: horizontal movement, vertical movement, if it's stretched, and if it's reflected. And those are the only things we'll be looking for transformations. So for this one, I know that it's a cube, so I know that my parent function is f of x equals x cubed. Now remember my transformations that I'm looking for, my 4 things is what's the horizontal movement, the vertical movement, the stretch, wider or narrower, and then if it's reflected. So I look up here at my equation and I see there's a plus 3 here. So that tells me that it's going to move left 3. I know it's left because remember the original equation has this subtract sign here. So because of the subtraction, I know that this one is the opposite of that. So it's going to move left 3, down 1. There's no number in front, and there's no minus sign, so I know there are no other transformations that take place. The domain, well, let's graph it first. If I put numbers in here, you could use your calculator. I can't show you mine, so I'm just going to put some numbers in. So now I have my points, so I'm going to plot them. I'm going to do one more. Negative 5 would be, let's see, 2 cubed is 8, minus 1 would be 7, so it would be down here. So here's my graph. Here's a little sketch of my graph. And notice I got specific points, and now I'm just connecting them. Arrows at the end because they do continue on. So now if I think back at what my parent function looks like graphed, my parent function looks kind of like this. If you compare these 2 points, this one and this one, you can see that to get to it, you have to go over 3 and down 1, which is where these numbers here came from. Okay, for my domain, my x, it continues, it is going out, even though it doesn't really look like it, and it is flaring out this way. So I can have all real numbers, so negative infinity to positive infinity, and the same with the range. Okay, so in this one we're looking at the cubic, and I'm going to add this other point. I think it helps. This is a cubic, so our parent function is f of x equals x cubed. The transformations that we're considering are our 4 things we have to look for. Our horizontal movement, and from our parent function, which looks something like this, horizontally to get from this point to this point, I'm going over 2, to the right 2, and I'm going down 3. Now if you notice there's no narrow, it's not narrower or wider, so I don't have to worry about my stretch. And it's not reflected, so I don't have to worry about the reflection. So the transformations would be to the right 2 and down 3. So how that's shown in my equation is, I know that it's going to be over 2 and down 3. Now remember that the general form of the equation looks like this. And so this subtraction makes this stay a subtraction because we want to go to that positive 2. Okay, so when we're looking at the quartic, we consider the same things. I know this is a quartic, so my parent function is x to the 4th. When I'm looking at transformations, I'm looking for 4 things. And for this one, it is, I'm going to go to the right 2, and I'm going to go up 3 when I graph it. There is no stretch, and there is no reflection. So only thing I have to worry with is this. So if I look at my parent function, the parent function is looks something like this. It goes through these points, but remember it's flatter than when we get down here near the origin, so it kind of flattens out a little bit. It's flatter than the squared. So my transformations for the equation that I want to graph now is to the right 2 and up 3. So I'm going to look, here's my vertex, and so I'm going to go to the right 2 and up 3. And then I'm going to pick these little points. And you could get a few more points on your calculator. Okay, so that's pretty much what that one would look like. Your domain is, again, all real numbers. You're looking at your possible x values. And your range is going to be a little different this time. It's not all real numbers because your y values start at 3 and go up. So I know that my smallest don't need that bracket. I need a hard bracket because it starts and includes 3, and then it goes to positive infinity.